We've been around since 1994. We're 40 years old. We're based in Stillwater, Minnesota, and we have several products. We have 3 products, and we do a great deal of MES services. We are partners with Canary, and we do a great deal of OT cybersecurity, so digital transformation, the operational intelligence, right? So we actually do a great deal of OT cybersecurity. How do we get this data and move this through the system in a secure and safe manner? Our locations are, we're a global company. We're headquarters, as I said before, in Stillwater, Minnesota. We have regional offices in in Canada, San Juan, Puerto Rico, Dublin, Ireland, Lyon, France, Mannheim, Germany, Pune, India, and Istanbul, Turkey. We also have projects and offices located all around the world. EIS's expertise is primarily around MES consulting and implementation. Canary, we do installation and training, the migrations, as well as deployment and user adoption. Architecture, system architecture, and of course the cybersecurity. And as you're going to see later today, later in this webinar, is the workflow.
No problem. So it's great to hear that a lot of the folks on the call already have some familiarity with Canary, but for those of you that have never heard of it, maybe this is the first time, I'm going to take you through just a little bit of kind of who we are as a company, but then also, what does the product really do? How does it work? And of course, you're going to see the actual demo here with Kevin in just a moment. But some of our company history is that we've been around since 1985, so that's going to be 40 years next year. To date, we have well over 20,000 installations, and currently the Canary system is used in every industry all around the world in over 70 countries. And the way that we go to market is primarily through our global network of system integrator and distributor partners, of which we have 130. And this really enables us to provide you with support on your projects in your time zone, in your language, and with expertise that really matches the projects that you're in. And then lastly, Canary is owned and operated by our original founders and their families with no outside investment or controlling interests. And this really allows us to have the greatest amount of control over the way that we develop our product and stay responsive to the needs of the market. So having already heard the name Canary several times, just to put it in the most concise nutshell that I can, and this is a bit of a mouthful, but the Canary system really is a time series data management solution that is purpose-built just for industrial automation. And what it does is it enables you to securely collect and store and contextualize and then analyze all of your process data on a single unified platform. And the core of the Canary system is a proprietary NoSQL time series historian database that's incredibly fast, incredibly high performance, really provides you with that scalability that you might be looking for. And it's also totally out of the box ready. And the goal here is that we want to help you make the most of your process data and just make it easy for you to use your process data. So the way that we go about this is really along the following 3 steps. We start by collecting and storing all of your data. Then we assign context to it. And then lastly, we maximize your operation. Now in the collect and store phase, this is going to be any edge device, any PLC, any protocol. We're going to collect your data at the edge. Then we're going to bring it into the Canary Historian where it's compressed smaller than anybody else, also using store and forward so there's no loss of data if the connection between the edge and the historian is lost. That data will buffer locally and then backfill into the historian when a connection is reestablished. But ultimately in step 1, you can log millions of tags, so well over 2 million per historian with true lossless compression. So we don't have a swinging door algorithm. We don't interpolate. We don't average data. We don't drop values over time like some of our competitors. You're going to have your real raw data forever. And it also has incredibly fast performance. So I won't go into all of that, but it is lightning fast, and we would encourage you to check it out. Now in step 2, of course, step 1, it's a great first step to have collected your data, but it's really not actionable information by which you can make better decisions until you have context assigned to it. So in step 2, we're all about helping you really see the story that your assets are telling. And the way that we assign context is really in 3 primary ways, which is going to be asset modeling. We have our calculation server, and then lastly, event monitoring. So these tools, you can always learn more about them at canarylabs.com, but that's what we're doing here in step 2 is assigning context. And then lastly, in step 3, maximize your operation. What that means, and really the tool that's primarily in use in this step, is going to be Axiom, which is shown there. That's the screen, there on the right-hand side, and you've got some trends and some donut gauges and some charts. But it enables you to analyze your operational health on any device and then make better decisions. And with visualization, you can build these dashboards, these trends, reports, and much more on your iPhone because it's built in HTML5, so you can have it on any device out in the field or locally. And then also from a licensing standpoint, we don't license any of our collectors, so you can collect an unlimited amount of data from any number of different sites with no additional cost. And also you can get the data out of the Canary system for free into any third-party application or platform with our data connectors. And that completely eliminates any platform lock or need for additional licensing there. So that's really kind of the crux of how the Canary system works. And we'll have a few opportunities at the end to discuss if you'd like to take next steps, but I'll hand it over to Kevin because he's got the best presentation that's really going to show you some of the power of the Canary system. So Kevin, I'll let you go ahead.
Okay. Kevin, can you talk to the architecture, please?
Absolutely. And Clark, I appreciate the intro with that because I don't want to spend a ton of time on the architecture other than the point that when you look at this, you're probably thinking, wow, that's really simple. You'll notice throughout this demo, that's the angle that we're working for. Throughout my time in the different industries, really trying to get things to the front line for an operator to use, we've got to have some basic things true. It's got to be able to be locally owned, which means we need either low code or no code options. You can't have to have a computer engineering degree to make a change to something. We need to make sure that it sets up very quickly and easily. If it's a long drawn out process, we've seen that people get bored and people don't pay attention to it. And then the last part is it has to hit a use case and show its value add immediately. It cannot be, you put this in and in a couple of years, everything's going to be great. It has to have a use case set up for it. The nice part about this is in a lot of these cases, the loop that you get into is pretty standard, and that allows you to take advantage of some commonalities. The two tools I'm going to talk about today are Canary, which you've heard introduced, and Ops Tracker. Ops Tracker has two modules. I'll talk about both of them. One is eDatasheet, which we'll show here, and then also eForms. Know that they're within the same architecture. They operate a little bit differently, and they're used for different things. eDatasheet is the manual data entry tool. This is literally taking a log sheet that you're taking a report on out in the field, taking numbers. Usually that stays on that log sheet. It sits in a drawer somewhere. Maybe somebody reads it. Maybe this hurts the worst. You make them put that number then into a computer program, right? So there's multiple handling of these points. eDatasheet, because Ops Tracker has SQL on the back end, as it's written, gets written to a SQL table. So not requiring that to the second level of information recorded changing, we can take advantage that this is human recording time, and SQL tables can control that and handle that pretty easily. So therefore, we don't really need that historian portion. The nice part about it, though, is if we do want to do calculations with that information that was saved, we can now combine that in Canary with other process variables, and we can have it do some really cool things, and we'll talk about that during the demo. So it becomes valuable because that information I recorded once is now digital, but just because it's digital, what can I do with it? And I want to see it so I can do some trend analysis, and I want it to do some actions for it so it can drive me to an activity. Again, if we talk about this control loop of an operator getting an input, synthesizing it, figuring out the output, and then moving forward, it sounds like a control loop, right? And really everything we're trying to do on the front line as much as possible is checking, does actual equal expected? And if actual equals expected, good to go, right? Green thumbs up. However, if actual does not equal expected, and we're assuming we understand the reasons why it would be, right? Then you now have to know, well, how do I bring the system back into the part where actual equals expected? And so you have to do some synthesis of that, and then you have to drive an action. And that's what we're going to show in this demo is how we pass that information back and forth. As I go into this demo, Jack, if you can throw it over to the demo. One of the things I want to make sure I'm bringing up is I am looking for tool sets that easily allow me to bring a solution to bear. So in this instance, we're going to be talking about operations in a water utility plant. So I have here we go. I'll share my screen. Now, this could be any plant anywhere that you're looking at, but you can imagine handing an operator, right? And I'm going to turn my camera off so you don't have to look at me while this is going on. Let's see here. So what we're focusing on is an operator collecting data in the field through sampling, in this case, a manual sampling process, where they are checking, does actual equal expected, right? Now, expected is a range of numbers we've given it to be in, right? And actual is what they're going to the field and measuring. Now, the part about it though, is for us to know whether that is in spec or out of spec takes a human to take those two values and, like Clark brought up, contextualize it. Understand not only is it inside those boundaries, but has it changed drastically over a set period of time? Do we see a trend appearing? That's from that manual data that we usually enter and look at as if it was the matrix streaming numbers down where we pick out patterns. And that's how we've had to do it with paper in the past. The nice part is once you digitize that, you get much more context and richness in it that allows the human brain to really see pattern recognition much easier. And we'll look at that with the demo. But the other part about it is we don't want to just look at it for pretty pictures. We want to look at it because we're collecting these numbers, because if these numbers are not within this band, we want somebody to take an action. Now, this is a list of instructions, which based on which plant you're in may look really familiar or may look super advanced or way not advanced at all. And that's really where we are in our operations and that maturity, right? Do we have a sticky note next to the computer SCADA screen, or do we have pages and pages of SOPs? The answer is it doesn't matter, right? Because each step of what we're supposed to do is based on an analysis of some kind of value. What we've done in the past, unfortunately, is we've made our people the analysis point. That worked great when we used to spend a ton of time training those individuals and we had a bunch of institutional knowledge. The issue is now, as the workforce is changing, we're bringing new individuals in, we don't have time for them to do 30 years in the job to get to that level of knowledge. What we need to do is take that level of knowledge that we know is out there in the operations in the floor and build bumper lanes for new operators. Now, will it mean that they can operate like a 40-year operator right off the bat? Of course not. Not going to happen. You need that knowledge. You need to be in the field. You need to be doing the operations. However, we can do a little life hack and maybe steal the first 2 or 3 steps of let's keep you in a safe place. Because right now, if you notice, we're talking about treatment goals. What is the impact if we don't get this right? Okay, well, we may overdose or underdose the water, which is a cost based on chemical feed. Fair enough. Well, we may not dose this correctly, and then we can't send that water downstream because it doesn't meet the requirements of a regulatory agency. Ooh, now we're talking some impact. In a chemical organization where you're now mixing chemicals, if you don't get these things right, there may be unintended consequences that can cause damage and pain and agitation within a system that can really hurt people and potentially kill them. So when we're talking about maintaining a system in control and returning it to control, it is ultimately about safety. Once you have a safe, controllable system, then you can do the optimization on that. And that's really what we want to do here, is get it into a safe, controllable solution. So assuming we give this to an operator, we now say, hey, go out to the floor and we're going to have you take some logs. Now, the 2 tools I'm going to use for that, one is called Ops Tracker, and we have multiple modules within Ops Tracker. For this portion, and please notice this is HTML, so you could imagine this being on an operator's pad out in the field with 2 tabs open, one with the visibility of what's going on in the plant, the other with a manual data entry screen. Okay, so we're going to use the eDatasheet module within here. And you'll see that we can actually take logs on a lot of different things in here. So I'm going to pick the clarifier. And you'll notice for the clarifier, I actually have a couple different forms that we can run. I can actually adjust the feed rate because when I do so, it's not on a digital signal. I want to track it though still. I want to visualize it. So I'm going to enter it digitally. So when the person goes and changes that feed rate, instead of putting it on a piece of paper on a clipboard, we're going to digitally enter it into the system so it can be seen along with all the other information. Show you that one later. But the treatment sampling is what we want to do now. Go out and take this sampling. So we'll hit treatment sampling. And you'll see what they need to take is here. Now, you'll notice there's no preformed timestamps. When I hit the plus sign, it comes up with right now. The fun part about this one is through pretty simple configuration. You can change whether this appears time now, whether it's every 2 hours, whether you're able to actually change this time, because I took this sample actually not now. This was 10 minutes ago I took the sample, so I want to record it then. These are all easy configurations within the eDatasheet platform. I'm going to do something really quick for the video portion. These are not programmer hands. I am not a programmer. Everything that I will show you is low code, no code, is drag and drop. It has to be if we want people to own it and use it on the floor. If it's not, it's going to be too complicated of a tool. It's outside of the scope of what we want our operators to know about, and we're not going to have them use it. We've got to make this Easy enough, the running joke in our company that a Kevin can use it, right? This has got to be, how do I solve a problem with these tools? Okay, so I'll take my video off. So in this tool, you can see that you can enter numbers, and I'll put them all within specification at this point. And you can see as you go through and record these numbers, and let's just say I put one, I fat fingered, didn't put the decimal in. And I go back and I go, oh, wait a minute. Oh, actually it's supposed to be 11.2. I hit save. These data points are now written to Canary. Now, you may say, okay, so why? Well, step one is because if you looked back on that measurement page, the two measurements I cared about the most, because they're actually the only ones that I had true actions off of, were magnesium hardness and total hardness. So now as an operator, as I enter this information that usually just lived on a log sheet, I can now go to Axiom, which allows me to visualize those two key parameters. I focus my operator's attention to that stuff they just entered. Why? Because this is what I've said is important for the operation of the plant. So this screen that you're looking at now is Axiom. Axiom allows you to do multiple different things. The first being of what we were showing is manual data entry. This is now allowing you to see those points. The reason is because those points are now in the Canary Historian. You also have access to any other points you've connected to the historian. As you can see over here, I've got two pump flow meters that I've got that are reading real-time information from the plant. Another thing, and I'll show you how we get to this in the background, are this daily flow accumulation. So that's actually using these flow rates summed up over a day, calculated at midnight, because some operator really cares about what that value is, right? And they say, hey, you've got to know that to be able to run the plant. Okay, great. Well, instead of making that operator go and have to pull that data, let's give them that information right here. What is important? What do we need to know? And then we'll talk a lot about this. This is an event table. So now as an operator, I can see every time here, I see, oh, wow, that was out of the specification high. That's why it's red. I can see what happened, how long it was in that case, and I have that historical reference of what's going on here. Now, as far as visualization tools go, Axiom hits everything you're looking for and then some, right? It's easy to use, it's easy to configure. I can easily add new functions on here. There's nice little delta because that's what you really care about, right? Is the difference between two numbers and timestamps. That's the main thing you're doing when you're looking at these. So that's built in already. You can do annotations, which is huge, which now allows you to add an annotation on the chart when an event occurs. So when the next operator is there and looks back, not only does it say, yeah, it was out of spec, but it may give you a reason why and help you understand what has happened on your watch station while you haven't been there, on your machine. And once you start giving that information and handing that off, right now, we're really doing that through mouth-to-mouth turnover, right? And everybody's fought the battle of the turnover log. What happened on the shift before mine? Once you start aggregating all this information in real time digitally, now you have that group knowledge. Now everybody knows what's going on. So that's what we're starting with here as far as data entry, being able to look at the data and what Axiom allows you to do as far as visualization. So now we're going to go into it. So this is our green thumbs up. Everything's going well. I have nothing on the screen that tells me I should do anything. I'm doing okay. Now I have to go back and I have to do another sample. So now I'm going to do a sample. And again, I know there's a whole bunch of stuff I had to sample. I don't remember what makes me do something or not, but I'm just going to put the numbers in. So you know what? We're going to say they're this is now at 45. This is now at 45. This is 11.1, and this is 110. So I've got a couple different things out of specification. Now, anybody who's worked in water chemistry knows that, man, these problem sets are fun because the way water equilibrium works, some things may go out of a band while another is coming back into equilibrium. Knowing that will be the spec and setting those boundary conditions up can be fun, can be really complex. We don't have the time to really go into that depth, but what we need the operator to do is go, hey, wait a minute, I put numbers in, what should I do next? And the best way I could explain this is if you could shrink your supervisor and have them follow around with your new operator on their shoulder and ask them as they put a number in, okay, is that a good number or a bad number? Okay, if it's a bad number, what should we do about it? Okay, what do we do? And that's how a lot of us have been trained in these operations. The problem is we don't have that anymore. We don't have that reinforced as much. So if we don't have that reinforced within the way we're training, and we don't have that with the new group of operators coming in, we need to be able to digitize that for everybody's sake and for everybody's safety on this point. So now the operators enter this information in, they come back to their main screen and they notice there is a button here. Well, that's great, because before there wasn't a button, because they did not have to do anything. What this is going to take advantage of, and I'll show you the behind the curtains part here in a second, right, is the conditional formatting required to say, yes, we are in an out of spec condition. Yes, it is an event. And yes, we need to do something about it. How that's visualized here. First of all, you'll notice there's a new event on the list of events that's occurred. There's no endpoint to it because it's currently active. So the operator sees there's an event in progress right now. And I can tell them, because of what measurement I'm making, what type it is. Because there's total hardness I should be checking. There's magnesium hardness. So I'm in a magnesium hardness out of specification. I can look over here. I see it's red. I am high. Okay. So I can see all this information. The other nice part about it is it now gives me a button. Here's the behind the scenes portion. This button is conditionally formatted off this. I know you can barely see it grayed out here. This is a calculational output that says whether we are in a out of spec condition or whether we're within spec. What we've done conditionally, it says when this is true, make that button show up. When it's not true, make it invisible. The ideal here goes back to old Lean Six Sigma, what's called poka yoke, error removal. Let's not give someone an action to take if it's not necessary. If we know it's necessary, let's take them to the part of the procedure that's necessary instead of having them go through all the options and choose your own adventure, right? It's up to us knowing the right answer to help provide this as much as possible to that new operator to make sure the same thing happens in a standard way over and over again. So we have the tools to do that now. So you can see it will launch off here. Now, as I kick this off, it's going to launch off, as you see, another URL. This URL will bring you to another tool that another part of the module that we're using from Ops Tracker called eForms. eForms is really the dynamic workflow of how you can get through returning the system back to its normal state. Now, the first two steps, if you notice, say no operator action required. So I didn't touch anything as an operator once I launched this. Again, it's up on my pad. When it stops, it tells me you need to increase line feed. From those entry points you put in, if you go back and look at our original sheet, you'll notice that because the lime, it was too low, it was too high, so we need to raise lime. So this is directly from the treatment goals that either the supervisor or the plant engineer put out on how we want to run this plant. Now it is getting integrated into an actual operation of, hey, go increase lime feed. Now, is this a checklist? No. A checklist is a linear follow through where it says you do step one, do step two, do steps three. So realistically, could you write this in a checklist program? Absolutely. That said, hey, I did the calculation. I saw I was in a high condition. Go do these steps. However, what Ops Tracker brings to you in eForms is dynamic decision making. And how this happens is, if you can see right now, it goes step 1, 2, 3, 5, 6, 7. The reason is the first step is actually defining a data point that is in the Canary Historian that I want to go read. And says, hey, where do I want to go within the historian to find a data point? This is the data point that was just recorded. And it says, hey, this is the data point you want. This is what it is right now. You could imagine if this wasn't a manually entered data point, if a decision was made based on a tank level or a flow meter, that you would want the most up-to-date reading of it and not hope your operator saw the right number when they made their decision. If you've got that digital signal, because of the ability for eForms to use API and the ability for Canary to allow that API function to happen, we can read real-time process variables and allow that to drive what action should be taken. So in this case, again, it was a manual entry point, but you could easily see how something else could drive this. Now, I'm going to show you the hidden steps. Because what happens here in an easy, again, I showed you my hands, no code way, right? It's an if statement. It says, hey, if you're greater than 40, show me these actions. If you're less than 20, show me these actions. Very simple if statement built in there. But again, if you look how any procedure has been written, there's always a decision point with multiple outputs based on some kind of analysis. And that analysis, we usually leave up to a human to make. A lot of the times my argument is, well, we should know that number. We shouldn't ask them to go check something if we don't need to. We shouldn't make that decision point even appear because we already know what the answer is. Why are we asking them the question? Now, no argument the fact that there will always need to be certain points for human interaction, absolutely necessary. Something you're not going to be able to digitize, sure. But for the stuff you can, let's remove those obstacles for the operator. So instead of the operator going, oh, I can't remember if I'm supposed to do this or this, let's give them the right path. So you'll see that it tells you to increase the line feed, and then it tells you to go resample. The other thing we can do with this, so you don't think that every procedure you have to create all these intricate steps, I'm sorry, it'll go to the next one, is that you can do cut and paste. So notice I did not rewrite the total hardness test. There's no reason for me to. You've got it either written, on a piece of paper. We've scanned in some interesting things to add on here, right? It can become a reference document if you want it to, or you can just plain embed it in here, right? And this cut and paste allows me to see what's going on. But if you're going to do that, you might as well add in some of the digitization. So if you notice in this whole procedure, it tells you that to get to your magnesium hardness, you actually have to do total hardness and calcium hardness, take the difference, and that gives you magnesium hardness. Okay, so I have to do these two tests where I'm doing titrations, but there's a little bit of math in here. Now, again, not to undercut anybody with their math, but I know I've done backshift math before, and it's come up with some really interesting information. And I've made bad decisions off that really bad calculation I did because I forgot to carry the one. So if we're trying to help our operators out, let's have the easy math done for them. So I can put in, instead of what this is, I can actually put in how much I titrated. So I titrated 2 milliliters there, and then it tells me my calcium test. And again, do you need this for every single thing? No, of course not. But this shows you the functionality and what you can bring to the table. Because now you can have the operator, instead of trying to do something on a scratch piece of paper, go, oh, I need to enter the number 10. Of course, that math doesn't work out of what you should be having in there, but you get the gist is this will bring you to that point and you can complete this process. You now have visibility that the corrective actions that you required, again, based on this sheet, how do you know this is occurring? You now have digital record that this has occurred. So every time there was an enter, every time there was a data point, that is all saved and auditable. The ops tracker was actually, the whole tool was built for a tool meant to be auditable, which means even in this small loop, you still get that functionality. So we'll go back and assume that I resample. It tells me to resample my hardness. I can save. And this, of course, is what we're looking for. How do I see something out of condition and return it to condition? And this may be multifaceted. This may be a cascading error that I have multiple procedures that I need to dynamically go through. Awesome. This tool is built to go through that quickly. So I go back to my main screen and I'm back in spec. I'm back with the line is no longer red. I don't have my button here anymore. So even if I wanted to, I couldn't go take extra actions, which I'm finding out in operations is almost as bad as doing nothing, is doing the wrong thing, not knowing why, and then trying to explain it later, right? And I have, this will pop up in a second as the calculation completes for this. So that's the front end of what we're working on here. But I want to show you the really cool power of this is the back end of this, because the back end of this, if you will, is Canary. And the visualization, while impressive, is super simple, which is great in itself. But the really impressive part is the ease on the back end for both setting this up and building these scenarios. I will tell you from the ops tracker side, building that eDatasheet took roughly 5 minutes. Building the eForms, for me, again, I've been doing this for a while, but 30 minutes. Building the Canary portion of this with calculations involved, 1.5 hours. In this tool is everything you'll need to answer those questions of does actual equal expected? And tell me which use cases you have to ask that for, because now you no longer are limited to what is available from a digital signal. Now that you can manually enter data, all those other points that you couldn't afford to put a meter on, that you couldn't afford to track and trend because it, to digitize it was just way off the wall, that's fine. You have somebody capturing that right now, probably on paper, and you're now having to look through it in Excel. Or you're looking into a historian pulling stuff out with Excel. But if you put it all into the same digital place, you can do this stuff in real time. And Canary allows you to do that. Here's why. You can have multiple connections into your Canary Historian. So here, Travis is actually the name of one of my workstations. So here's, we've got pumps running live PLC data points. Under eDatasheet, you just saw the data that goes in there. It's what I'm manually entering on that eDatasheet, all gets historized here. And then I have calculations because as I'm running through this data coming in through multiple sources, I'm integrating it together. You can see that off of your Calcs and Events page. And this is really where the simplicity, again, as I'm looking for what tools can I put in place where it's not going to be thrown on the shelf because, yeah, no way am I reading that booklet. This is for the sticky feel of, yes, we can use these tools because they're built to be simply implemented right away. So here's my magnesium hardness, the calculation I created here. Again, looked like we were doing a lot of fancy stuff, but we weren't. We were measuring what our current magnesium was, which you can see came from that data point that was from eDatasheet. We put in static values for high and low. We could make it really fancy if we wanted and do some calculation where the output was some running output and make that the high and low. But we'll stick with the basics here of that's what we saw on the sheet. Then we did a simple event start trigger calculation, which says, hey, if we're above the high or below the low, we need somebody to take some action. So let's start this event and let's call it magnesium hardness. So you'll see that's what it takes to calculate an event start trigger. Also notice over here, I didn't show you the email coming out, but you can put a notification email in, and this is what it'll look like for your email template. So again, while your operator may be in a distributed operations mode where, hey, they're running a couple different plants, they may not have time for the synthesis to remember they've got to do something. They may be moving to their next thing. They may need the backup of this system. They may need a supervisor as well to get this so that at the end of shift check, you can say, hey, did you make sure to hit A, B, and C? I saw you got that alert. Those are the kind of things that you can do with the Canary system on this. Nice part is then you actually have an end trigger where you can say, hey, when we're both in spec again, let's call it the end. And then because of this, you can set an event property that says, what's the important thing I want to know about this event? Again, from what you can see, I'm looking at operator turnover. So as an operator, I'd want to know, whoa, you went out of spec. How high or low did you go out of spec? What are we talking about here? And that's why I had the max of that valley or peak. So what is that max value? And that all can be shown as you saw on Axiom. You can change it so that it can calculate every time this value changes. So every time I put a new value in, this is like having that little supervisor on your shoulder. Do you need to do something? Are you in spec? What are your actions? The calculations that we also have out here that are pretty simple that we want to do in a lot of these cases are flow totals. There you go. That's the flow total. It's run each day, 24 hours a day, or at the 24 hour. So every midnight it's run. Therefore, I run this calculation once. It sums up what this is. Think about this used for regulatory reporting. You can think about this for dosing where you've done a rate times a time over a certain amount of time. A lot of times we have to go back in history, find those values so we can do an end of month answer, right? And visualization and report out. This allows you to do this in real time. If you're going to build that report and you're collecting that data anyways in your historian, you might as well be doing this in real time as well. Right? So that shows you how easy those calculations are. The one last thing I want to show you on here is that SQL connector. A huge power engine of this tool is its ability to connect to SQL. Again, for our tool, since Ops Tracker does have a SQL backend, it makes it much easier to connect there, as well as the fact of other relational databases, things that you may have, such as a CMMS system. Right? As you may have for a parts ordering system, as you may have for a light touch ERP, any of those systems that have that relational database through SQL now become data sources for what you can connect to without paying anything extra. And the hookup of them, pretty easy. I'll show you the configuration for what I'm using for eDatasheet. And in all intents and purposes, it says who you connecting to, where do you want it to save those data points, where's that permission, and how often do you want me to go find that data? And in doing so, I now can visualize, I can calculate, I can trigger events off things that before were sitting alone on a piece of paper that I hoped somebody was going to do something with, but I hoped. And now with Axiom being my visualization and workflow, the eForms being my workflow, I ensure that something changes here and gets you moving and doesn't just say, hey, something's wrong, but hey, something's wrong, and here's how you can fix it. And I want to back you up. So I'm going to stop there for the demo because I think I covered all the points I wanted to on that. I will turn it back over to Jack for the hosting.
Okay. Kevin, you want to go through just review basically what you just demonstrated?
Yeah, absolutely. And I just wanted this slide to be here. I know everyone's going to get a copy of this because when you go back and look, you're like, so wait, where was what happening, right? Which is good because these tools work extremely well with each other. And again, looking for a solution that is able to close loop these problems in a very light touch, easily implemented, locally owned way is why these tools, in my opinion, were chosen, right? So first of all, we recorded that data. That was eDatasheet, wrote to SQL, and then Canary was able to historize it. So that way I was historizing the manual data entry that I was putting in there. The next, and that was with the Canary Historian. Next, I took that data and then I visualized it, right? As well as events that I was triggering, which we'll talk about in a second, but I could put that all in front of an operator in a one-stop shop screen that allowed me to look at the historized data. Something I didn't even cover a ton in this is when you get a chance, go look at all the visualization options that Axiom has. There's several tools out there for visualization that require some additional widgets to kind of show data in a manner that is a way we're used to seeing it in. Axiom has those pre-built in, right? So Canary's really gone forward on making sure that the visualization portion is top notch on there. The next part is that we were using that manually entered data in the historian to do a calculation every time it was entered of actual versus expected. Show that to you in Canary Calc's really easy statement. Again, it's an or statement and an and statement, not doing any programming here. Then we use that to trigger an event saying, hey, are you in a condition or not? And that was the Canary Events, which was also part of that Canary Calc. It's called Calcs and Events, and it really blends well together because the only thing you'll want that will start an event is probably a calculation you figure out. The next being the condition-based link. And that's again, so that we only showed the button when the button needed to be clicked, right? And then we removed the button when you brought the system back into the standard condition. That was allowed through Canary Axiom, referencing the calculation output and then the conditional formatting for the button. The dynamic workflow was a nice play between Axiom from Canary and the eForms from Ops Tracker. So eForms has an ability to do REST API. So eForms can call, and in this case, I called to the Canary Historian, which has API access. Other things we could call from are, a web page that has information that we need about a price or a condition of something. We can also make those calls as well for REST API. In this case, we used it to the historian so that we could check on a data point in the historian to drive which actions we were going to take on a dynamic workflow, right? So that was the interplay between eForms and the historian on that one. And I think that's all of them.
Okay. All right. Thanks. Questions. One question was from Branko, is Ops Tracker a Canary product or a third-party product? And I answered that it is an EIS product. And he went on to question, what are the possibilities of bringing these functions into a Canary native product? I don't know what Canary's plans are of building a workflow engine. I don't know. Clark, do you guys have any plans on that? Mark?
Yeah, this is Mark Benninger. Yeah, the chances are we would not do something, a particular application like that. We're more of the data infrastructure group, the historian group. We rely on our partners like yourself to make those type of applications to lay on top of our infrastructure.
Okay, thanks. Question here, Kevin. What about a audit trail and the implications of what people have done, as well as the reports that they're and the forms and that they're building?
Yeah, no, appreciate that. So if you go to the EIS webpage, you'll actually see that Ops Tracker has been built for the life science industry. Anybody who's got some understanding of that understands that there's heavy regulatory requirements, a large portion being prove to me you did what you said you did, right? So for a long time, that was signature control. Hey, I made sure this occurred. He signed off on it to show it occurred, and another guy came over to sign off on top of that. And then our manager, she came over and made sure all of us signed correctly, and then she signed off on that, right? So, and it's got to be auditable to that point where you can prove it out. Moving the digital signatures, the pharma industry and the life science industry said, hey, you still got to prove this out. So when this tool was built, when Ops Tracker was built, and eForms being used in this, it is built to track everything. Every time you make a change to an attribute, to an entry, to a comment, it is all saved and can be called back up. Again, another plus of the SQL backend is because we're not changing things every second, we're changing them, every hour at most, minute at most, we're never going to fill up the SQL table. So we can use that SQL table as a bulk historian of a lot of other data, right? Who signed for what, when they signed for it, things of that nature. The good part about that is since it's SQL backend, accessing that data is any tool you can that can pull from SQL, such as Power BI, you can visualize those things. So you can actually look at the audit trail based on signature control of those things.
Okay, got another question here. Is it possible to set up data entry that records text, comments, operators, and people using the eForms?
So that would be, it depends. So eForms, absolutely. Both eForms and eDatasheet take any data entry point. One of the nice parts about eForms is you can actually, because you have a REST API, if you're permissioned correctly, you can both read and write from a historian. So we didn't do it in the demo, but with that API call, not only can I read from my Canary Historian saying, hey, what is this data point? I can manipulate things and then send back and say, hey, go write this to that data path. So I can write back to the historian. That means that anything that we can write to the historian can be pretty much saved and written. So that includes text strings, that includes lists, right? Enumeration lists, things of that nature. So a common use case with like an eDatasheet is you'll record information, but then there's always another set of information that you want that isn't digitally available, that qualitative information potentially, that you want grouped together, time-stamped with this, and you'd love to have in the same data set, but you've never been able to because one's on paper and one's digital. eDatasheet allows you to enter things free-form text, enter from a drop-down list of preset selections, so you can, have a shorter list of cause codes, if you will. And it allows you to capture that qualitative data with that quantitative data at that same timestamp. So it helps with what Clark was talking about earlier, the contextualization. The more data you can bring to an event, and the more you can bring to it, the more information, the more context you have about what occurred at that point. So eDatasheet can absolutely be a way to record those points.
Okay, thanks. Let me add to that a little bit. Not only can you do the reason codes and the reason, numbers, text, free format text, pull down lists, reason codes. You can also have filtered reason codes. So if, for example, you have a downtime, and the downtime is, let's say if you select, it's a product, and then you pull up then the next list will be types of product downtimes. Maybe there was poor quality, the product was a little lumpy, what have you. Another one might be, or if you selected, let's say the downtime was because of equipment failure. Well, now that pull down list is specific to an equipment failure type of downtime. Maybe it was high amperage, high torque, something along those lines. So you can actually nest these and build them out accordingly. All right, let's see. Question, Canary. Okay, this is more of a Canary type of a question for Mark or Clark or somebody. Can you guys convert, backfill in data from other historians if you decide to move from one historian to Canary?
Yes, we do that regularly. Pretty much any historian that's out there on your systems today, might need a little bit of help with the first step of converting it over to something we can use. But as long as we get into the right format, yes, we can convert it to Canary, and you won't lose any of that data.
Okay. Okay, great. Looking for any other questions? Okay. All right. Well, with that said, conclusion, please take the survey at the end, right? And a link to this webinar recording will be emailed to everyone who registered. And next steps, have any questions, reach out to myself, reach out to Mark Benninger from Canary, or myself, Jack at eisinc.com, or mbenninger at canarylabs.com. All right. Thank you very much for your time. And this concludes the webinar.
Thanks, everybody.